NASA says its Pilgrim 1, the most far-off human-made object in the universe, is sending usable records to Earth again. Inside the universe, we have no idea what it is, other than the fact that we can detect it. Pioneer 1, the infamous space probe launched by NASA more than 4.5 decades ago, has recently transmitted a message that has sent shockwaves through the academic community. After traveling almost 14 billion miles from Earth, Pioneer 1 has made a discovery so monumental that it has shifted its trajectory, turning back toward our planet. 7 minutes ago, Traveler 1 made a disturbing revelation, pivoting toward Earth. But what exactly could this discovery be? Could it be evidence of extraterrestrial life, a unique phenomenon, or something even more improbable? In this thrilling research, we will delve into these extraordinary revelations, as Pilgrim 1 has just made a shocking discovery, prompting it to suddenly change course toward Earth. Records of the Voyager twin probes suggest that if certain celestial events hadn't aligned, two of the most remarkable rockets ever launched might never have left Earth. In this case, it was the 4 largest planets aligning in our solar system approximately 50 years ago. These planets were slowly aligning in a configuration that last occurred during Thomas Jefferson's administration in the 19th century. This extraordinary planetary alignment went largely unnoticed until Gary Flandreau, a doctoral student in flight at the California Institute of Technology, identified its significance in 1965. At the time, space exploration was in its infancy. Working part-time at NASA's Jet Propulsion Laboratory in Pasadena, California, Flandreau was tasked with determining the most efficient method for sending a spacecraft to Jupiter or even farther, to Saturn, Uranus, or Neptune. Using only a pencil, he carefully plotted the orbital paths of these massive planets and made an exciting discovery. In the late 1970s and early 1980s, all 4 planets would align in such a way that they could be visited in a single mission. This alignment meant that a spacecraft could use the gravitational pull of each planet to slingshot itself to the next, significantly reducing travel time. Flandreau discovered that this arrangement could cut the flight time from Earth to Neptune from 30 years to just 12 years. However, there was a catch. This planetary alignment occurred only once every 175 years. To seize this once-in-a-lifetime opportunity, a spacecraft would need to be launched by the early 1970s. NASA seized this rare opportunity and built spacecraft to make the journey, Voyager 1 and Voyager 2. These twin spacecraft were launched on an extraordinary mission to explore the outer planets of our solar system. Thanks to the alignment of the planets and the visionary calculations of Gary Flandreau, the launch of the Voyager twin probes in 1977 was truly spectacular. On September 5, 1977, at Cape Canaveral in Florida, Voyager 1 embarked on its grand adventure into space, launched by a powerful rocket called Titan IIE Centaur. Just 15 days earlier, Voyager 2 had been launched on August 20, 1977. Voyager 1 took a shorter route into the vast universe, and their primary mission was to explore the massive gas giants in our solar system, including Jupiter and Saturn, along with their numerous moons. These daring explorers surpassed all expectations, venturing far beyond, pushing the boundaries of exploration, and traveling farther and longer than any other spacecraft in history. They set numerous records on their inspiring odyssey, reaching regions previously unexplored by humanity. Entering interstellar space, a completely unknown area within our galaxy, these pioneering spacecraft Voyager 1 and Voyager 2 are now more than 12 billion miles away from us. Despite their immense distance, they continue to astonish scientists with their remarkable discoveries. Most recently, they made a revelation so shocking that it has captivated everyone. The Voyager twin probes have achieved many extraordinary feats. Decades ago, they studied the moons of Jupiter and Saturn, surprising scientists who initially believed them to be dull and pitted like our own moon. These moons turned out to be vibrant centers of interest. Voyager 1 made history by becoming the first of the twins to pass by Uranus in 1986, and just 3 years later, it flew past Neptune, an achievement unparalleled by any other spacecraft. As these spacecraft continued their intricate journey, NASA employed several ingenious strategies to keep them functional. Non-essential components like extra heaters and parts were deactivated to conserve power, with a goal of keeping the spacecraft operational until at least 2025. For the dedicated scientists and engineers who have been part of this incredible mission from its inception, this is a mixture of emotions. Their hard work has paid off, and just when it seemed the Voyager missions were nearing their end, a stunning discovery emerged from the depths of space. At the start of their grand journey decades ago, the Voyager spacecraft amazed experts by providing the first close-up views of the moons of Jupiter and Saturn. These moons, which astronomers had believed to be dull and heavily cratered like our moon, turned out to be dynamic worlds. Voyager 1 reached Jupiter in March 1979, only 18 months after its launch. Voyager 2, following a slightly different trajectory, arrived in July of the same year. Each spacecraft was equipped with special cameras that used filters to capture full-color photographs. These cameras were designed to rotate through space at a rate more than 10,000 times slower than the hour hand of a clock, ensuring that the images they captured were clear and sharp. During their mission, the Voyagers took more than 33,000 images of Jupiter and Saturn, revolutionizing our understanding of these celestial giants. Its moons, each noteworthy, reveal new and entrancing data. For instance, Europa, one of Jupiter's 53 named moons, was found to have a broken, cold surface estimated to be over 60 miles thick. As the spacecraft departed from the Jupiter system, they gained a speed boost of 35,700 miles per hour from a gravitational slingshot, an essential maneuver that pushed them closer to interstellar space. Saturn, the Voyagers diverged. Voyager 1 passed through Saturn's brilliant rings, enduring countless impacts from small dust particles, before flying by Titan, a moon surrounded by an orange fog, and traveling north out of the planet's rings. Voyager 2 continued its mission, reaching Uranus and Neptune. In 1986, during its visit to Uranus, Voyager 2 discovered 10 new moons and added the planet to the list of worlds in our solar system with rings. However, Voyager 2's achievements were overshadowed by tragedy. Just days after its closest approach to Uranus, the Space Shuttle Challenger tragically exploded shortly after liftoff, killing all 7 crew members, including Krista McAuliffe, a high school teacher from New Hampshire who was set to become the first civilian in space. 3 years later, as Voyager 2 flew over Neptune's striking blue methane atmosphere, it encountered the fastest winds recorded on any planet in our solar system, reaching speeds of up to 1,000 miles per hour. Neptune's largest moon, Triton, was revealed to be one of the coldest places in our solar neighborhood, with surface temperatures plummeting to a chilling -235 degrees Fahrenheit. The moon's frozen volcanoes were another rare discovery, shooting nitrogen gas and particles as high as 5 miles into its atmosphere. After Voyager 2's captivating images of Neptune and its moons, both spacecraft were scheduled to shut down their cameras, marking the end of their official missions. However, astronomer Carl Sagan, a member of the mission's imaging team, intervened. Despite the official end of the mission, NASA extended it, hoping that the Voyagers could venture into interstellar space. Renamed the Voyager Interstellar Mission, the spacecraft continued their journey into the unknown. Voyager 1's interstellar journey took a stunning turn in August 2012 when it reached a remarkable milestone, crossing beyond the heliosphere, an immense region of charged particles created by the Sun. This achievement became widely known the following year when a study was published in the journal Science, sharing Voyager 1's groundbreaking discovery. The spacecraft's plasma wave instrument detected a strong solar flare between April 9 and May 2013. This event caused electrons near Voyager 1 to vibrate, indicating that the spacecraft had entered a region of higher particle density than that found inside the heliosphere. Initially, it seemed surprising that electron density is higher in interstellar space than near the Sun. However, researchers explained that the electron density at the edge of the heliosphere is much lower than on Earth's surface. By analyzing Voyager 1's data, scientists pinpointed the spacecraft's exact exit date as August 25, 2012. This determination was based on electron movement and measurements of charged solar particles gathered by the spacecraft on that crucial day. For the Voyager team, this announcement was a source of immense pride and excitement. Susan Dodd, the mission director, expressed the team's delight, saying, "We are pleased to have been able to continue working with the Voyagers and to see it achieve the remarkable milestone of entering interstellar space." Ed Stone, a key figure in the Voyager missions from the beginning, emphasized the significance of this achievement in advancing our understanding of space. He said, "Voyager 1 has led us to new discoveries by providing us with a first view of this new region, expanding our scientific knowledge of the nature of energy and radiation in space." Voyager 2 also crossed into interstellar space in November 2018, venturing into an uncharted region beyond the Sun's protective bubble, which shields us from cosmic radiation. However, the truly astonishing news comes from Voyager 1. Following an incredible 46 years, NASA's Voyager 1 spacecraft, the most distant human-made object in space, continues to send valuable information back to Earth, despite its extraordinary distance of over 14.7 billion miles. The spacecraft remains operational, even though its primary mission officially ended long ago. Here's where things get truly fascinating. Voyager 1 recently made an incredible discovery that has left scientists both perplexed and deeply concerned. As Voyager 1 traveled through space, something extraordinary occurred. It began transmitting data back to NASA, revealing an anomaly in its trajectory. The data it sent indicated signals containing information about an unknown phenomenon that defied explanation. This anomaly appeared to suggest the presence of a massive, previously undetected object exerting a tremendous gravitational pull, distorting the spacecraft's path. This discovery has sent shockwaves through the scientific community, sparking a whirlwind of speculation. Could it be a rogue planet, a black hole, or something even more extraordinary? The implications are staggering. If confirmed, this newly identified object would dramatically reshape our fundamental understanding of the universe. NASA has assembled an emergency team of scientists to investigate further, utilizing all available resources to analyze the data and potentially redirect Voyager 1 to gather more information. This stunning twist in Voyager 1's journey serves as a reminder of the vast mysteries that lie beyond our planet, and the enduring spirit of exploration that drives humanity to seek answers in the farthest reaches of space. The spacecraft, equipped with 3 radioisotope thermoelectric generators, had an expected operational lifespan of 4 to 12 years. Remarkably, Voyager 1 has far exceeded expectations, continuing its mission for an astounding 45 years. Unlike solar panels, these radioisotope thermoelectric generators produce energy by harnessing the heat generated by the radioactive decay of plutonium-238. Despite this remarkable durability, NASA estimates that by 2025, the Voyager spacecraft may no longer be able to generate enough power to operate its instruments and transmit data back to Earth. During routine communication with Voyager 1 through NASA's Deep Space Network, something extraordinary occurred. After over 40 years of consistent data transmission, NASA's computer systems on Earth began receiving a strange transmission that left everyone concerned. For the first time in its mission, Voyager 1 suddenly halted its journey and performed a complete 180-degree turn.